As we have previously learned, evolution is defined as the change in allele frequencies of a population over time. Regarding a similar term, community selection is defined as the genetic changes within species that make up a community. And the genetic changes occurring can alter species interactions within the community. In other words, species that live together change together. Community selection has a tremendous impact on the ecosystem. But in what ways? And is it a good impact or a bad impact? Well, stay tuned to find out more. Imagine that you have two soccer teams, all with players of the same age and physique, but the only difference being the number of years that the teams have played together. For one of them, they've played together for 5 years, and for another team, they've played together for 15 years. Which team do you think will win? Perhaps you said the team with more years of experience playing together, right? But what led you to make that choice? Well, it is probably logical to assume that a team with more years playing together would have developed a stronger team chemistry and have essentially learned how to effectively play together. Everybody is aware of each other's strengths on the team and knows how to utilize that talent in ways that will lead to more wins than a less experienced team. Well, this scenario can also be seen in plants through the relationship between community selection and plant productivity. Based on previous experiments, there's a positive correlation between biodiversity and ecosystem productivity in terms of biomass. Furthermore, these experiments show community selection favors a community with greater biodiversity. This biodiversity improves ecosystem functions, which are processes that moderate the changes in energy, nutrients, and organic matter. These functions lead to the development of ecosystem services, which come to us in the form of renewable resources and are a sign of an overall productive ecosystem. As supported by the data collected in Morcell's study, as well as in previous research by Zupinger, it has been shown that biodiversity is directly proportional to efficiency, production, and the stability of a community. Production was determined by measuring the biomass of plants in the naive community and then comparing it to the biomass of plants in the selected community. Selected plant communities were seedlings used in the various soil types, while naive plant communities were seedlings that were purchased straight from a supplier's fields. The experiment found that productivity was higher in the selected plant group than the naive plant group. In order to test the relationships between species richness and biodiversity, the researchers built two types of experimental plant communities. One of the communities was composed of plants with a history of 8-year co-selection. The other community was composed of communities with identical species composition. The communities were monitored over 4 years, and the results showed that the selected plant community had greater community-level functioning. A statistical analysis ANOVA test was conducted for this data, and the p-value was less than 0.05, which means that the results are statistically significant. Our world involves a constant interaction between the living and the environment. Each organism has a different role in creating a balanced ecosystem, and looking at community function mechanisms can reveal the importance of how, for example, each ecosystem benefits from coexisting species, whether it be creating more biodiversity or plant productivity, or even how natural selection can arise in a community. This understanding is key to decisions like introducing a new species to an environment or seeing the effect that an endangered species has on a community. Clearly, biodiversity factors can have a significant impact, and the observations from Van Morcell allow us to see this importance, that every change, every species, every action has an effect, and some communities are stronger in surviving changes than others.